All right, so we are going to take a look at a previous free response question. This would be a non-calculator. And basically we have a graph, and our graph is of the function f. So what we know is that f is a continuous function from -4 to 3, whose graph consists of 3 line segments, as well as a semicircle. We are told that g is So we are told that g of x is equal to the integral from 1 to x of f of t dt. So essentially this is a fundamental theorem of calculus problem. It's testing your knowledge of what does the integral of a graph represent. Well, what that means is that this is really the graph of g prime. Part A says find the values of g of 2 and g of -2. So what we're going to do is find g of 2. So basically that means everywhere you have an x, it becomes a 2. So it's from 1 to 2 of f of t dt. So we just investigate that graph, and we go from 1 to 2 on our graph. So what we'll notice is that's a small triangular region. So the area from 1 to 2 is a triangle. So area of a triangle is 1/2 base times height. So the base is 1. The height, now this is the tricky part, is -1/2 because the graph is below. So 1/2 times 1 times -1/2 would make g of 2 -1/4. Now, g of -2 is the integral from 1 to -2 of f of t dt, which is the same as negative the integral from -2 to 1 of f of t dt. So now we can just use the area under the curve on our graph. So -2 is here, and +1 is over here. So what that means is we actually have 2 different areas we're going to investigate. We're going to investigate the area of the triangle from -2 to 1. So the area of that triangle, again, there's a negative out in front of all of this, would be 1/2. The base is a width of 1. And its height is, so 1/2 base 1, height is 3. So 1/2 base times height plus the area under the curve, which would be negative. So that is a semicircle. So it's 1/2 pi r squared. So in this case, our radius is 1. And again, it's negative because it's below. So we get -3/2 minus a minus when you distribute that becomes a +1/2 pi. So the area under the curve is 1/2 pi -3/2 pi, meaning that the value of g of 2 is -3/2 plus 1/2 pi. Okay, so part B asks us to find g prime and g double prime. Once again, finding g prime is an application of the fundamental theorem of calculus. So if I want to find the derivative of g, that's like finding d dx of the integral from 1 to x of f of t dt. So we know that the derivative of the integral is simply the value. So g prime of x is really just equal to f of x. So g prime of -3 is the same as f of -3. If we go over here, f of -3 is 2. So g double prime of x would be like f prime of x. And f prime, if we recall the definition of the derivative, simply means the slope or the rate of change at that point. So g double prime of x at -3 is the same as f prime of -3, which is representative of the slope at -3. So if you look at this graph, it goes -4, 1, it goes -3, 2, and -2, 3. So it's going up 1, right 1, up 1, right 1. Therefore, the value is 1. All right, so part C says find the x-coordinates of each point at which the graph of G has a horizontal tangent line. So let's first review where do horizontal tangent lines occur. Horizontal tangent lines occur when the derivative is equal to 0. So in this case, we are looking for the points at which f of x is equal to 0. So those points occur at -1 and 1. So for the first part of this, we know that g prime of x will equal 0 at x equals -1 and x equals 1. For the second part, it says for each of these points, determine whether g has a max, a min, or neither, and then justify. Well, we know that in order for a function to have a max or a min, then we need to have a sign change. So we need to look at the graph and say, okay, is there a sign change? Does it cross the x-axis? So at x equals -1, g prime of x goes from positive to negative. Therefore, g prime of x at x equals -1 is a relative max. Because it goes from positive to negative, it means that g of x was increasing to decreasing. And again, this part's not important, just kind of reminding you what that means. Now, at x equals 1, g of x is neither a max or a min because g prime of x does not change signs. We can look at the graph and see it goes negative and then to negative again. Because it doesn't change signs, we cannot have a relative max or a relative min. Therefore, this is a neither. Okay, part D for -4 to 3, so we're going beginning to end. Find all values of x for which the graph of G has a point of inflection. So, where do point of inflections occur? Point of inflections occur on the second derivative at the points at which the second derivative is either equal to 0 or does not exist. So basically we're looking for the critical points. So the critical points tell me the possible, so that's a PPOI. An actual POI has to have a sign change so in this case, since we're talking about G double prime of x, we would need F prime of x to have a sign change. Since this is the graph of F, we are looking for the extremas. So we have an extrema at -2. We have an extrema at 0. And we have an extrema at 1. So basically, G double prime of x is the extrema of f of x. So G of x has a POI at x equals -2, 0, and 1. Because exactly what we just said, G double prime of x or F prime of x, either one is fine, changes sign at each of these points. You could also say that F of x changes from increasing to decreasing or decreasing to increasing. That would also work as a justification.